This is lesson 5.3, Inequalities in One Triangle, starting on page 348. Use the exterior angle inequality theorem to list all of the angles that satisfy the stated condition. So the exterior angle inequality theorem says that an exterior angle of a triangle will be greater in measure than its two remote interior angles. So for example, on number 1, the measure is less than the measure of angle 4. So angle 4 is an exterior angle for this triangle right here. So 3 is the angle that is next to angle 4 or adjacent to angle 4. Therefore, 1 and 2 are the remote interior angles. So angle 4 will be greater than 1 and 2, or in other words, the angles less than the measure of angle 4 are angles 1 and 2. Number 3, measures greater than the measure of angle 2. So if 2 is less than the measure of angle 4, then 4 is greater than the measure of angle 2. Also, if we look at the entire triangle here, we have an exterior angle, angle 9, and its two remote interior angles would be angle 1 and then angles 2 and 7 added together. So angle 9 is greater than the measure of angle 1 and greater than the measure of angle 2 and 7 put together. Therefore, 9 has to be greater than the measure of angle 2. List the angles and sides of each triangle in order from smallest to largest. So our sides from shortest to longest would be 1.7, which is CB, then 2.8, which is AB, then 3.1, which is AC. Then we have a theorem that says that the smallest angle will be opposite from the shortest side. So since BC is the shortest side, our smallest angle is going to be angle A. Then opposite from 2.8 is C. And last, opposite from 3.1 is our largest angle, angle B. Number 7, the support on a hang glider form triangles like the one shown. Which is longer? The support represented by side AC or the support represented by side BC? Explain your reasoning. So is it going to be this side of the triangle or this side of the triangle? Well, 44 would be opposite from AC, and 64 is opposite from BC, and we're looking for the longer side. So the longer side will be opposite from the greater angle. So since 64 is the greater angle, then that makes BC the longer side. So BC is the longer side, and once again, to explain your reasoning, BC is opposite 64, which is greater than 44. Use the exterior angle inequality theorem to list all the angles that satisfy the stated condition. So number 9, measures less than the measure of angle 4. No, I'm sorry. Measures greater than. Oh yeah, measures less than the measure of angle 4. So angle 4 would be an exterior angle to this triangle. So its two remote interior angles would be less than it. So that's these two angles right here, 1 and 2. On number 11, measures less than the measure of angle 9. So angle 9 is an exterior angle for this triangle, and its two remote interior angles of this triangle would be 6 and 7. And then it's also an exterior angle for this entire triangle right here. So its two remote interior angles would be 3 plus 6. So if it's greater than 3 plus 6, it's got to be greater than angle 3. So angle 3 is less than 9. And then also the other remote interior angle for 9 is angle 1. Number 13, measures greater than the measure of angle 7. So for angle 7, we have an exterior angle right here. So 6 and 7 are remote interior to 9. So therefore, if 7 is less than 9, 9 is greater than 7. Also, for this triangle, we have an exterior angle up here, 5. So its two remote interior angles would be 7 and 8. So 7 and 8 are less than 5, or in other words, 5 is greater than 7. And there you have it. Once again, we want to list the angles and sides of each triangle in order from smallest to largest. So on number 15, our shortest side would be RT, which is 4, then RS, which is 5, then TS, which is 7. So our smallest angle will be opposite our shortest side. So opposite from 4 would be our smallest angle, angle S. Then opposite from 5 would be next, so angle T. And then our largest angle will be opposite our longest side, and that's angle R. On number 17, our smallest angle is 49, angle L. Next is 52, so angle P. And then our largest angle is 79, angle M. So opposite from our smallest angle will be our shortest side, so PM. Then next would be opposite 52, which is ML. And our longest side will be opposite our largest angle, so opposite 79 is PL. On number 19, in a right triangle, the two acute angles are complementary. So 90 minus 46 would give us 44. So angle C is 44 degrees. So we can list our angles, smallest to largest. So that would be angle C, then angle D, and then our right angle, 90 degrees, angle E. So opposite from our smallest angle would be side DE. Then opposite 46 is CE. And then of course opposite 90, our hypotenuse, is going to be the longest side, DC. So on number 21, the wedge below represents a bike ramp. Which is longer, the length of the ramp, which is XZ, or the length of the top surface of the ramp, which is YZ? Explain your reasoning using theorem 5.9. Okay, so since we have a right angle here, we know that these two angles, Y and Z, have to add up to 90. So therefore, Y would be less than 90. So we know that our angle right here is less than this angle right here. So from theorem 5.9, if Y is less than X, then opposite from that would be XZ has to be less than opposite from that, YZ. So once again, which is longer? That would have to be YZ. YZ would have to be longer, so the surface of the ramp, because it's opposite from a greater angle, and that's how we would explain it. And if we divide by 4, x is equal to 43. And then we'd substitute that back in. So we have 43 minus 1, or 42 degrees. We have 43 times 2, so that would be 86 plus 3 is 89. And we have x plus 6, so 43 plus 6 would be 49. Now we can list our angles from smallest to largest. So that would be angle P, followed by angle Q, and then angle M. And then our shortest side will be opposite from our smallest angle, so opposite 42 would be MQ, followed by opposite 49 is PM, and finally opposite 89 is PQ. Use the figure at the right to determine which angle has the greatest measure. So on 25, is it 2, 4, or 6? So 2, we have an exterior angle, and by the exterior angle inequality theorem, our exterior angle will be greater than the 2 remote interior angles, which inside of this triangle would be 4 and 6. So the greatest angle there would have to be angle 2. On 27, 3, 11, and 12. So 3 is our exterior angle, 11 and 12 are interior angles inside of this triangle, so 3 will be the largest angle. 29, 8, 10, and 11. So 8 is here, 10 is here, 11 is there. So we're looking at this entire triangle now. 8 is our exterior angle, 10 is a remote interior angle, and 11 plus 14 is a remote interior angle. So 8 obviously is going to be our largest angle. Use the figure at the right to determine the relationship between the measures of the given angles. So on 31, angle BCF would be this angle, and CFB would be this angle. So 15 is greater than 14, so angle C is going to be greater than angle F. So angle C is greater than angle F. Angle BCF is greater than angle CFB. For number 33, angle DBF would be this angle, and BFD would be this angle. So 12 is greater than 5, so opposite from 12 will be greater than opposite from 5. So angle BFD must be greater than angle DBF. Use the figure at the right to determine the relationship between the given lengths. For 35, RP and MP. So RP is this side, MP is this side. So we have to first look at our angles. So first off, this angle right here, since we have a straight line, those three angles have to add up to 180. So if we subtract 60 and 85 from 180, we would get this angle is 35. And then these three angles have to add up to 180. So 70 and 35 is 105. If we subtract that from 180, we get 75 for this angle right up here by P. So from there, we're looking at RP, which is opposite 70, and MP, which is opposite 35. So opposite from 70 would be our longer side. So RP has to be greater than MP. For 37, we're looking at RM, so this side, and RQ, this side right here. So we have these two angles, 85 and 30, so if we add those two together, we would get 115, and if we subtract that from 180, we would get 65 for this angle. So then we have to look at both triangles and then compare the two triangles related on their shared side. So our shortest side would be opposite from 30, so that's RQ, followed by PR, and then finally PQ, because that's opposite 85. Then if we look in our other triangle, excuse me, our shortest side would be MP, our middle side would be PR, and our longest side would be opposite 75, which is MR. So first we want to look at this inequality. We have MR has to be greater than PR inside of this triangle. So MR is opposite 75, PR is opposite 70, so MR is greater than PR. And then if we look inside of this triangle, PR is longer than RQ because PR is opposite from 65 and RQ is opposite from 30. So PR is greater than RQ. And then we just take out the middle here, and we can say that MR therefore is greater than RQ, or RM is greater than RQ. And on number 41, list the side lengths of the triangles in the figure from shortest to longest. Explain your reasoning. So once again, we want to subtract these two angles from 180. And if we do that, we would get 47 for this angle, and then subtract these two angles from 180, and this angle ends up being 55. So let's order our sides in the triangle on the left first. So our shortest side is opposite 47 because that's our smallest angle. So we would have AB followed by, next is opposite 62, so BC, and then followed by our longest side, which is AC. And then order your sides in the other triangle. So opposite from 42 is BC, and then opposite from 55 is CD, and opposite from 83 is BD. So now we have to put these together. We have AB is less than BC is less than AC, and then we have BC is less than CD is less than BD. So the conflict here is BC is less than AC and BC is less than CD. But we don't know about AC and CD, what order to put those in. So we look here and we notice that we have some lengths. So this tells us that AC is shorter than CD because this is 10 and that's 12. So then we can finish our order here. So altogether we would have AB, BC, AC, then once again CD because 12 is greater than 10, and then followed by BD, the longest side of this triangle. And that's it.